Imagine you need to test a login form with 20 different combinations of valid and invalid inputs. Valid email, wrong password. Invalid email format. Empty username. SQL injection string. Special characters in the password. You could write 20 separate test functions, one for each scenario. But that means 20 functions that are almost identical, same structure, same page objects, same assertions, just different input values. That is a maintenance disaster waiting to happen. If the assertion logic ever changes, you have to update it in 20 places. Data-driven testing solves this. With data-driven testing, you write one test function and feed it a list of inputs. Pytest runs that function once for each set of inputs, reports each run as a separate test result, and clearly labels which input caused a failure. 20 test cases. One function. If the assertion changes, you update one line. This is one of the most important skills in professional test automation because real applications process thousands of different data combinations. Writing a separate test for each one is not realistic. Parameterizing your tests is. In this episode, you will learn how to use pytest.mark.parametrize, how to load test data from external files, and how to structure your data-driven tests for maximum clarity and coverage. Pytest's parametrize decorator is the core tool for data-driven testing. Here is how it works at the most basic level. You decorate your test function with it pytest.mark.parametrize, pass it the parameter names as a string, and then pass it a list of values. When Pytest runs the test, it iterates through the list and runs the function once for each value, substituting the parameter each time. If you have multiple parameters, for example, username and password and expected result, you pass the parameter names as a comma-separated string, and each item in the list is a tuple containing all the values for that run. Pytest automatically generates a test ID for each run based on the input values, so when you look at your test results, you see exactly which combination passed or failed. You can also assign custom IDs to each tuple using the pytest.param function with an ID argument, which makes your output even more readable. For example, you might label your test cases as valid-login, wrong-password, empty-username, and so on. Those labels show up in the test report and make it instantly clear which scenario failed without having to decode the raw parameter values. This is especially valuable when your input data contains long strings or special characters that would make the auto-generated IDs hard to read. Hard-coding test data directly in the parametrize decorator works for small sets, but for larger datasets you should load from an external file. CSV files are the most common choice. Here is the pattern. Create a folder called test_data at the root of your project. Inside, add a file called login_data.csv with headers, username, password, expected_result. Each row is one test case. In your conftest.py, write a helper function that reads the CSV using Python's built-in CSV module and returns a list of tuples. Then pass that function call directly to your parametrize decorator. Pytest evaluates it at collection time and generates one test per row. This approach has several advantages. Your test data lives outside your code, so non-technical team members like product managers or manual QA engineers can add test cases by editing a spreadsheet without touching any Python. The test data is version controlled alongside your tests so you can track what changed when. And you can have multiple data files for different features: login data, search data, checkout data, each managed independently. For Excel files, use the OpenPix library. The pattern is the same: a helper function reads the file and returns a list of tuples, which gets passed to parametrize. Keep the loading logic in conftest.py or a separate helpers module so your test files stay focused on assertions. Let us put this all together with a real example. We have a login page object from episode 15. We have a CSV file with test data. Now we write a single parametrize test that covers every scenario. The function signature looks like this: def_test_login takes driver, username, password, and expected_result as parameters. The parametrize decorator above it passes in the list of tuples from the CSV loader function. Inside the test, you create the login page, navigate to the login URL, call page.login with username and password, and then branch on expected_result. If expected result is success, assert that the current URL contains dashboard. If expected result is error, call page.get_error_message and assert it matches the expected message text. When you run pytest and the test fails on row 7, pytest shows you the exact input values from that row, the assertion that failed, and the actual versus expected values. You know immediately what broke and why. Compare this to 20 separate test functions. Each failure would require you to open the function, read the hard-coded values, and then trace the logic. Parametrize gives you that same coverage with a fraction of the code. This is the approach used by professional automation teams at companies with hundreds of test cases per feature. A few advanced patterns worth knowing. First, you can stack multiple parametrize decorators on one test to get a Cartesian product of all combinations. If you parametrize browser with Chrome and Firefox, and parametrize username with 3 values, pytest runs 6 tests, all 3 usernames in both browsers. Second, you can combine parametrize with fixtures. Your driver fixture can itself be parametrized to run the same test in multiple browsers, which is how cross-browser testing works in practice. Third, when some parameter combinations are invalid or not applicable, use pytest.mark.parametrize fail inside the parametrize list on those specific rows to mark them as expected failures rather than skipping the whole test. Fourth, for very large datasets, consider filtering your parametrize list in the loader function based on an environment variable. In CI you might run the full dataset, but during local development you only load the first 10 rows to keep feedback fast. Fifth, give each parametrize case a meaningful ID using pytest.param with the ID argument. When you are looking at a CI report showing 100 test runs, IDs like valid login, empty password, and SQL injection are infinitely more useful than the raw tuple values. These patterns separate a basic parametrize implementation from one that scales cleanly to a production test suite. Recap time. Data-driven testing lets you run one test function against many input combinations. Pytest's parametrize decorator takes parameter names and a list of values or tuples. External CSV or Excel files keep test data out of your code and make it accessible to non-engineers. Parametrize tests produce individual pass or fail results for each input combination, with clear labels in the report. You can stack decorators for Cartesian products, combine with fixtures for cross-browser testing, and use pytest.param for custom IDs. When a specific combination fails, you know exactly which input caused it. Together, episodes 13 through 16 have given you the foundation of a professional Selenium test suite, browser control, a structured framework, maintainable page objects, and scalable test data. In the next episode, we are going headless. Headless browser testing removes the visible browser window so your tests run faster, use less memory, and work perfectly in CI pipelines where there is no screen. That is episode 17. Subscribe to QA Career Lab and I will see you tomorrow. And if you are building out your automation portfolio as you follow this series, every episode gives you a concrete, demonstrable skill you can talk about in interviews. Data-driven testing is one that interviewers love to ask about.